on a normal, remember normal? On a normal weekend, we would be out in the field watching birds and enjoying the outdoors, and then come back. And there was this gap of several hours, and we decided we could do something with that time, and that's how what we originally called works became the Symposium, which I think is a better term for it. Our very first one was, I'm getting an echo because Pam just signed in. Just move to the other end of the table. It's very disconcerting. I can hear myself. Anyway, the very first one was on climate change, and that was a number of years ago. So Audubon's been on that issue for quite a long time. Today, we're going to hear about conservation ranching, small-footed bats, Cerulean Warblers of the Buffalo River, and feather mites. I want to thank the Newton County Public Library because I have a very slow internet connection at home, and they have given me the run of the library with just Pam and me and a cat named Pepper here in Newton County Public Library. They've got a very fast student. And also I want to thank Dan Scheinman for his technical expertise in setting this up, and Audubon Arkansas system. And of course, our 4 speakers. If you stick with us through all 4 and can answer 4 questions based on the 4 speakers' information, you have a chance of, for a drawing, to win $50 gift certificate to the National Audubon store. So it's something to keep in mind, and we'll tell you how to enter that contest. There are lots of, I think we've got some people on here who are not Audubon members or said they were going to sign on. So just very quickly, I wanted to let you know that there are, somebody once said to me, oh, there are an awful lot of Audubons in Arkansas there. And I said, well, not really. So the way I break it down is that there are really 2 Audubons in Arkansas. There's the Arkansas Audubon Society, which is what you're participating in right now. That's the state organization. It's not technically affiliated with National Audubon Society. And then there is Audubon Arkansas. So you'll sometimes hear Audubon Arkansas and Arkansas Audubon. Yes, those are 2 different organizations. Audubon Arkansas is the state office for National Audubon Society. And if you're a member of an Audubon chapter, of which there are, I don't know, 6 maybe right now in the state.
8 of them.
8 of them now? Wow, great. So if you're a member of one of those, you are also a member of National Audubon. So all of those chapters, the 8 chapters, are really National Audubon. So just 2 of them to help get things squared away on that. Now I'm a little bit ahead of the time by quite a bit. We could start and go right into the program. Let's wait another minute just to give people a chance, and then we'll be ahead of ourselves so that if we have questions or something we want to deal with, we won't panic about the timing. Pam wants to know why she can't see herself. And so there's a question. Up at the top, you can see a little blue arrow. If you click on that, you can see the other people that are. Yes. All right, Marshall, if it's all right with you, I think maybe we'll start a little bit early here. And Marshall Johnson is Vice President and Executive Director for Dakotas. That's both North and South Dakota. He's responsible for all the Audubon programs and projects and initiatives in the North and South Dakota. And I won't go into all the details, but that's a pretty large job. It includes managing a 5,000-acre wetland and grassland complex. He's also chair of a 6-member board of directors of the North Dakota Natural Resources Trust. And lots more to that job. I first met Marshall when we served together on a National Audubon Board staff committee to conceptualize the conservation ranching program. I think that was at least 8 years ago. But it's remarkable from that, just the concept, how rapidly it's expanded and grown since then. So obviously Marshall is extremely busy, and we're very grateful that he's willing to share some time with us and talk about birds and how people can benefit from the conservation ranching program. If you're taking the quiz, pay special attention to what Marshall says about the relationship between greenhouse gas emissions and cattle. So I'm going to turn it over to Marshall. Welcome. And do I have to do anything?
No, I think I've got it. Can you hear me, Jack?
All right. We sure can. Great.
Good deal. Well, there's few things that I never don't have time for, and one of them is Jack. I so appreciate all of the work you've done. I often tell folks within Audubon, if it weren't for that committee of board members spearheaded by folks like you, Jack, by the chairwoman, Ms. Walker, and Christy Patterson, there wouldn't be a conservation ranching program. And we're so glad to have this opportunity to explore different ways of conserving grasslands. And so I'm very thankful for our continued friendship and working together, and really appreciate what you've done to help us have an opportunity to flourish and conserve grasslands through a pretty innovative approach. So really appreciate that, and appreciate, I think I must have met Dr. Dan, it's got to be 10 or 11 years ago now, possibly at a Together Green training, or, it's got to be 10 or 11 years somewhere back east, maybe a fly-in or something. What do you think, Dan?
I'm not quite sure, but it has been a while since we've known each other. But we don't get to work together enough. Hopefully that'll change.
That'll change soon. Really happy to be with you all. I'm always giddy when I can talk about conservation ranching and talk about grasslands in general. Grasslands are, you talk about spirit ecosystems, are spark birds, are things like that. And most of those birds for me live in the prairies. And it's something that I've always been very passionate about. I grew up just kind of north of what we call the Blackland Prairie in Texas, just south of Garland, Texas, and have always been enamored with grasslands since I was a kid. And grasslands don't pop like the mountains, they don't rush over you like the oceans and rivers and seas, but there's a subtle magic to grasslands. It's been said anyone can love the mountains, but it takes soul to love the prairies. And I would certainly agree with that. And I think we all know that grasslands are in more than just a bit of trouble. And the conservation ranching program was born out of that realization more than 9 or 10 years ago now, that the tools that were at our disposal for conserving grasslands were coming up short. Certainly for the last 100 years, we've done a lot of easements, and we've done a lot of CRP, and we've done a lot of different programs to acquisitions, and you name it, cost share programs. But in all of that, we have conserved less than 5% of this ecosystem, an ecosystem that was once the most ubiquitous native ecosystem in North America, playing home and providing sustenance and life for humans on this continent long before America was here, and many thousands of years ago. And now we're losing the prairie. And we know that the drivers of prairie loss, primarily row crop agriculture, urbanization, and just plain land management approaches have degraded or eliminated the prairie in vast swaths of the country. And so this began again 9 or 10 years ago as an effort to explore a new way of conserving grasslands, a new way of conserving grasslands and tying grasslands to where people live. Rural communities like the one I live in here in North Dakota. Maybe many of you might live in Arkansas. The prairies, that's where the prairies are at. That's not necessarily where people are at. And so this was another part of connecting conservation outcomes to food, actually allows us to engage bigger swaths of people. And so that's a big part of why we started this program. And it was born out of a realization that no cow, no grass, no birds. More than 95% of grassland birds and grassland songbirds are born on land that is either owned or managed by cattle ranchers. And so they have to be a part of the solution here. And that's kind of how we started off down the road of creating what has now become the largest bird-friendly regenerative grazing and beef program in the country. Certification programs are wrought with complexity and challenges, mostly in the area of scale. And what we did, thanks to the National Audubon Society Board task force on this issue, we really tried to learn as best we could from the examples that have come before us, and maybe not met the challenges or seen the success that they ultimately would have wanted to do. You know, a lot of the reports that are coming out now are illuminating something that those of us that have spent a lot of time in grasslands have known for quite a while. We're losing our grasslands. Our Audubon released our grasslands report in the fall of 2019. That same year, as you all know, the 3 billion birds report was released by the Cornell Lab of Ornithology and many others. And it detailed what we see out in the field, and that is grassland birds are declining at a rate faster than any other suite of birds out there. And that in and of itself is alarming. But when you think of all of the piping plovers and shorebirds, like plovers, that actually a big portion of them are also obligate species to grasslands. The Great Plains piping plover population, the majority of that population actually nest in prairie alkali wetlands here in North Dakota, South Dakota. You see that though the birds that are diminishing the fastest are all obligate species to grasslands. It's a big red flag, and again, when you look out, be it not for the legend here, that dark brown blackland prairie would stretch out historically into southwestern and central Arkansas. And you can see the before and after over the last 100 years. We've lost roughly 55 to 60% of grasslands, but in areas like the eastern tallgrass prairie, the northern tallgrass prairie, we've actually lost 99 or more percent of that. So it's when you look at the drift prairie, we've lost significant amounts of those areas, and to mostly row crop conversion and urbanization. And then, you know, over the last 15 or 20 years or so, we're starting to see vast swaths of what is remaining in the mixed grass and short grass prairie taken over by eastern red cedar. It's been estimated in this central grasslands area, an area the size of Oklahoma has now encroached upon what remains of the grasslands in terms of by way of eastern cedar tree encroachment. And eastern cedar tree and other anthropogenic structures on the grasslands, be it wind towers or trees, or poorly placed fences or things like that, have a impact on grassland bird nesting success. And when we're thinking about grassland bird conservation, we have to be as dynamic as these birds are. You think about the long-billed curlew that spends its winters in the coastal prairies of Texas and Central America, makes its way up through the Central Valley of California, and obviously nests here in the shortgrass prairie of the Northern Great Plains. We have to work everywhere to truly have an impact at scale on this species population and overall sustainability. And that's where the conservation ranching program comes into play. Ostensibly, it's a certification program, but we always wanted this to be more than just a sticker on a package of beef or bison. We wanted it to be something that we could scale in a way that each conservation ranch, enrolled ranch, was empowered to produce the more birds than ranches that aren't enrolled in the program. And we wanted to demonstrate that we could produce birds, more birds, we could sequester more carbon in the deep root systems of these regenerative managed grazing lands. And we could produce, obviously when you're doing that, you're producing more pollinators, and grasslands play a vital role in removing toxins and chemicals out of our river streams and tributaries. So we really wanted to use this program to manage for all of those outcomes in a positive fashion. And so we created this certification program. In creating the program, it's really about creating a values-based supply chain where we start with, and everything we do starts with, the desire to increase grassland bird quality, habitat quality. And that's for birds, that's for other wildlife, that's for pollinators, bees, butterflies, and whatnot. But also to make that work, we have to make ranching profitable for ranchers that are enrolled in the program. Because to meet the needs of pollinators, bees, and birds, it's not just about keeping grass right side up. It's also about reducing the amount of chemicals that are in play on a given ranch. And so ranches that are enrolled in this program, they're committing to no neonicotinoid pesticide use, a reduction in herbicide treatments within the ranch, and an overall reduction in chemicals that are used. We have to make sure that insect populations are healthy on these ranches, because what do grassland birds eat during the nesting, brood rearing periods of their life cycles? It's insects and seeds and things like that. So we have to make sure those are on the ranch, and we have to make sure that we, through a program like this, are rewiring the way consumers, or the way birders, there's 48 million birders in this country. We have to make sure people understand the connection between good ranching and good bird habitat. They are inextricably connected. And again, early on, as Jack could probably tell you, we there was building something like this from the ground up. There was thought, well, we just need to worry about birds and that's it. And really, when you're building this virtuous supply chain, it has a start with birds, but we also have to think about climate. We have to think about using this land to store and purify more water in a watershed, and create better outcomes for the ranches that are enrolled in the program. There must be an incentive to do something like this. Again, on top of what I mentioned before in terms of some of the things the ranches are committing to by enrolling in the program. They're also committing to never use antibiotics or hormones. These are pasture-raised and grass-fed animals, so there's no feedlots associated with the Audubon seal, because a part of this is also making sure that the animals and livestock, a part of these operations, are cared for to the best of our ability. And so the protocols that each ranch adheres to is broken down into habitat management, animal health and welfare, environmental stewardship, and forage and feeding. And that's the way that we come at better grassland birds outcomes. Again, is it's starts with, you know, stocking rates and rotational grazing and regenerative practices that create what you probably have heard Dan talk about, the structural heterogeneity out on the landscape that creates a mosaic of different habitats that grassland birds are going to need at different points of their life cycle. And so we're really trying to make these ranches or get them towards being kind of a Cadillac ranch in terms of birds. It's and other wildlife. It's the place you want to be, so to speak. Early on, there was a lot of question as to whether this program could ever scale, if it had the buoyancy and the incentive to scale. And we've been really happy with the amount of scale and interest we've had in the program. Today, this program is eclipsed about 2.4 million acres. Just around, I think we're just over 100 ranches now, and these are cattle ranches mostly, but we also have bison ranches enrolled in the program. Bird lovers and Audubon members and people in general can have a box of beef delivered to their front door in all 48 lower 48 states. I believe actually it's all 50 states now. So it's really creating a incentive for the ranches to do better, but also an incentive for and an opportunity really for people who care about birds. If you know, we're not encouraging people that don't eat meat to eat meat. When we started out, we did a feasibility study on our membership. Most Audubon members eat some beef and have some beef in their diet. This is just a way to maximize the impact of beef or bison wherever it may lie in your diet, and it ties back to specific outcomes for birds. It's important when we started this program, a couple things were really important for us. Number one, that this was a living program for the life of a ranch's enrollment. It wasn't just a checklist. Okay, you're not doing this, you're not doing that, great, great. That's where I think we get tripped up with organic certifications, where it's just more of a checklist of what you're not doing. The Audubon Conservation Ranching Program is actually more about, yes, it starts with a strict never ever on the conversion or destruction of native perennial grasses, absolutely. The never ever on neonicotinoid pesticide use, absolutely. So there are a list of things that are never ever, but then it's more about what you're actually doing. And so what we do with our protocols at each ranch, we step the protocols down to an eco-regional level where we take a list of grassland birds and their needs, and we build a management plan year in, year out for a ranch that's going to manage specifically for the needs of those various grassland bird species, target species. And I think that's really important with a program like such as the conservation ranching program, or a program that is selling certain values in the marketplace. It's really important that we are building an accountable tool. For Audubon, we do not check our own homework. Certainly we work with our ranches year in, year out, but we have Food Alliance that comes in and actually verifies as a third-party auditor that the ranches are doing what is required under the Audubon protocols. We also do annual bird monitoring, typically using either Missouri River Bird Observatory protocols or the Bird Conservancy of the Rockies IMBCR protocols. And those are considered, both of those are considered kind of really good, the best of the best in terms of not only the protocols, but it's an extensive database of ranches that are and areas that are monitored through those protocols. Certainly, we've seen the anecdotal evidence from ranches that have been enrolled for a while that they're seeing a lot more birds, but we can't judge a program like this purely or merely on anecdotal evidence. And so we created, not only do we conduct the bird monitoring, but we've created a proprietary tool called the Bird Friendliness Index. You may have seen this advertisement in the last Audubon magazine on the back page there, and it shows we're starting, it's early in the program, but we're starting to see when we roll up all of the data from our ranches, we're starting to see when compared to other ranches in close proximity and within the same region, we're starting to see our ranches are doing better for birds than ranches that aren't enrolled in the conservation ranching program. We're going to continue to monitor the Bird Friendliness Index, both at an aggregate level for all of ACR, but also on a ranch to ranch level. And that we take that data and we feed it back into the annual habitat management program, our plans, which helps us make tweaks here and there. Maybe we're not leaving enough nesting cover on the landscape during these periods, and we make tweaks. We go, maybe there's some fencing need here that's causing maybe a drop of Henslow sparrows, and so we need to leave more cover out on the landscape for Henslow sparrows. That kind of helps us close the loop and continue to manage for our target bird species and have data that helps feed into that management. One of the things that makes this program really attractive in terms of the conservation community is just the program efficiency from a dollars and cents standpoint. When you look at, we deliver this program for about $1 an acre. And that includes the monitoring, the delivery of technical assistance, and the third-party verification, all of that. And we'll probably, when we incorporate soil carbon monitoring across all of the ranches, we'll probably tick up to about $1.50. But in comparison to other conservation programs, you think about CRP. In my part of the world, CRP goes for about $1 or $128 an acre. And there's a grazing version of CRP, which is $26 an acre, and that doesn't include administration. That's just the incentive payment. If we can build a robust group of millions of bird lovers who also happen to eat beef that are willing to look for this green seal, the sky's the limit in terms of scaling good grassland bird habitat. And in terms of cost effectiveness, there's really no comparison. And that, we didn't know that early on that this would be, when compared to other cost share programs, so efficient, but it really has turned out to be. Carbon sequestration. One of the really important things I think we must do when, and any conservation group must do when working with cattle, is assess and manage the possible and inevitable climate impacts of animal agriculture. We've really tried to base this program on science. We feel that we base our support of properly managed and regeneratively managed animal agriculture on science. And knowing that without any animal agriculture, our prospects of conserving what's left of the grassland ecosystem are pretty nil. And so we've really tried to use science and partnerships and this moment that we've been in to find a middle ground that is not merely centered on opposing interests, but centered on what birds need, and specifically in this case, grassland birds. And so in the next year, we're going to be incorporating soil carbon monitoring on all of our ranches, because properly managed grassland habitat actually sequesters carbon out of the atmosphere and into the root systems of those perennial native plants. Here in the Northern Great Plains, we estimate that each acre of rotationally grazed grasslands have roughly 30 to 50 metric tons of carbon stored underground. And there's some noise and variability year on year, but on average, it's about 40 to 60 metric tons per acre. That's a lot of carbon that's stored underground. And as we lose between 1 million and 1.5 million acres of grasslands annually, there was a study from World Wildlife Fund here about 3 years ago that showed just with the grassland conversion in the Northern Great Plains between 2009 and 2015, the emissions equivalent to 670 million cars were emitted into the atmosphere. So not preserving grasslands and conserving grasslands really doesn't give us a opportunity to meet the needs of climate change. And so part of our grazing methodology is in encouraging practices that help set the soils up for storing and sequestering more carbon out of the atmosphere. Moving forward, we hope to scale this program, double the enrollment over the next year and a half. We're poised to do that. We've raised more than $4.5 million in the last year to expand this program. We're really excited about that. Obviously, wherever I go, wherever I talk, I really encourage folks to, if you do eat beef, if you know someone that eats beef, please direct them to this program. If you love birds and you eat beef, I would hope that every package that you buy has the green seal on it, because it actually means something. If you want an option, one of our best partners our best market partners is Blue Nest Beef, and you can go to bluenestbeef.com and check those folks out. Some of the folks that started Blue Nest Beef actually helped us design this program 8 or 9 years ago, and now they've come back to help us scale the program. And what's great about Blue Nest Beef is the amount of premium that they pay to our ranches in exchange for the habitat management that they're doing for grassland birds. Blue Nest Beef only sources their products from ranches that carry the Audubon green seal, which is really special. With that, I would again encourage you all, if you eat beef, you care about grassland birds, please look for the green seal and really put a different kind of power into the purchase that you make. It's been said, and I love the quote. It means a lot to me. Every time you spend $1, you're casting a vote for the world that you want to see. And that quote and that thinking is really at the heart of what we've created in the conservation ranching program. So appreciate you guys listening, and appreciate your time.
Oh, thank you, Marshall. You have time to hang in for just a few more minutes in case there are questions?
Absolutely.
Okay. one of the things I love about this program is that it is a prime example, pun intended, of a market-based solution, and Audubon positions itself as a centrist organization. And Audubon works across the aisle. The idea that birds have no party is central to the way Audubon works. And I think this is a wonderful example of it. Just a couple of weeks ago, we had our first order of beef from Blue Nest Beef. And right now, my daughter's freezer is full of great beef. We tested it out and really enjoyed it. It was more flavorful. And from what I read, it's also healthier. I have just sent everyone a link to a PBS program that Susan Harden alerted me to. It was on a few days ago, and if you click on the link that I just sent you, you'll find out that if you think you're getting organic grass-fed beef from America, take a look at this very short video. It turns out that a lot of the beef that's sold by Walmart and a lot of the other big chains actually comes from Nicaragua, and they can still say it's US beef. Very often they are destroying forest habitat and indigenous communities in order to grow this beef. So you think you're doing the right thing, but it turns out you're not. And I really encourage you, if you doubt it, to take a look at that PBS program and learn the true story. And Marshall, I'm so glad to see you're still enthusiastic about this after all this work that's gone into it.
Oh, absolutely. And just to underscore your point there, I think it's a great one. I had a chance of reading that article or watching that article, and 80% of grass-fed beef is imported in America. And when you see the green seal, 100% of that comes from American ranchers that are doing good things for grassland birds. And I think that's really important. It's not about being against imports, but there are some in a lot of those imports are coming from places that are doing some pretty devastating things to the ecosystem.
I noticed Robin has asked, why is eastern cedar taking over? She's wondering if it's a lack of fire or...
That's exactly it. The suppression of fire is really the leading cause of eastern cedar tree encroachment. And we're trying to get more fire on the landscape. We have a number of programs aimed at doing that and try to head off the eastern cedar tree encroachment. But it is really the root of the problem is climate, but also the fire suppression and the lack of prescribed fire out on the landscape and habitat fragmentation.
All right. How do you find potential ranchers for the program?
They find us. There's been so much interest in the program, and we try to target specific landscapes that have very high ecological diversity. There's still a lot of native ecosystem on the landscape. And then the third component of vetting opportunities and vetting partnerships and where we want to deploy this program, at least in this pilot phase, what's the threat of loss? That's really huge. When you get into tipping point, where it's election time and you think of, the bellwether counties, there are some bellwether counties for grassland birds. If you could draw a line from Manitoba down to the Gulf, and there's a line there where we really want to work in the prairie pothole region and down through the eastern edge of the mixed grass prairie, because those are counties and townships that still have maybe 35 or 40% of grassland left in the township. But the projections are for those townships like Stutzman County here in North Dakota to go from maybe 35% grassland cover to 5% in the next 15 years. So those are kind of those counties where we're seeing the wave of conversion take place. And we early on, we kind of took the low-hanging fruit. As we continue to grow this program, and obviously I see a question from Barry on finances. Obviously, funding is a big part of how we can continue to grow the program. As we do that, we want to be more intentional about targeting those regions that are real bellwether counties and landscapes for grassland birds.
I've got a question that was just handed to me, not from the cat. Grass-fed versus pasture-raised. Can you explain the difference?
The difference is supplemental feeding of grain. We, early on when we started the program, we wanted to give some leeway to folks that were making that transition. Feedlots or confined feeding were they're never ever. It's not allowed in the program. But there is some allowances at a small ratio for bunk feeding out on pasture. We wanted to kind of create kind of a bridge for people. So it's a grass-fed pasture-raised program. We did an audit of this earlier this year. And what we found out was the fact of the matter is 96% of our ranchers are actually fully grass-fed in terms of the animals that they market under our program. And so we're actually looking at transitioning over to a 100% grass-fed and finished program. But currently, the main difference between pasture-raised, and I don't want to go down a rabbit hole here, but true pasture-raised. There's some fake pasture-raised, and pasture-raised has generally gotten a bad rap because pasture-raised to us means always out on pasture. Technically, USDA allows, you could have an animal confined fed, but if you open the gate, even if you have a bunker full of grain, if you open the gate, it's technically pasture-raised. That's where pasture-raised has gotten a bad rap. We don't allow that. Most of our ranches actually do no grain supplemental feeding, but when we started out, that was technically allowed.
Another question, are any Arkansas cattle ranchers enrolled in the program?
Not at this time. Arkansas, Iowa, Illinois, Wisconsin, I'd say those are Florida. Those are states that we would love to expand the program to those states, the Pacific Northwest as well. When I stepped into this role leading the conservation ranching program nationwide last year, I really wanted to take a breather in terms of expansion and really build the resources and the sophistication around delivering the program, and take a moment to learn some lessons after 3 years of being in pilot phase. And one of the things that we want to see as we move into new areas, we want to see that strong market, that strong interest from birders, from consumers, that they want this program in their state or in their region, and then bring the ranchers on. Getting ranchers to adopt bird-friendly practices is the easiest part of this. Sounds counterintuitive, sounds strange, but if you have an incentive, to put this in context, for our ranches that source to our biggest market partner, Blue Nest Beef, a couple weeks ago, the beef market, the conventional beef market, was $1.10 $1.68 a pound hanging weight. The grass-fed organic market was $2.25 a pound. Blue Nest beef pays Audubon Conservation Ranchers $2.85 a pound. When you have that type of incentive and premium, and you have a market in place, there's not much that ranchers won't do in terms of habitat management and managing for birds to have a consistent market. And so we probably had the cart before the horse maybe 3 or 4 years ago in wanting to get acres, and then build a market, kind of the field of dreams, build it and they will come. We really want to make sure that we're preserving those relationships with ranchers. And so we want to build with chapters and our conservation partners. We want to build a market in a state. I can tell you, if a state gets up to 500 people that say subscribe to Blue Nest Beef, you can enroll about 15 or 20 ranches right like that. 500 people make that big of a difference. And so we're starting to want to build the excitement, the interest, and the subscriptions through our various market partners before we launch a pilot program in a state. But I can tell you that we've done some research, and literally 500 people is really a game changer for this program moving into a new region.
Wow, sounds like we've got a project here in Arkansas we could work on.
If you get to 500 subscriptions, I can't tell you no.
I tried to talk Ozark Natural Foods in Fayetteville into it, so I'm going to go back to them, and anybody else who shops there can talk them into it as well. Another question here, and maybe this should be our last one. How long do you plan on collecting bird data?
I think as long as we have a certification and a ranch is carrying that certification, at least every other year, they should have on the ground, in-person bird monitoring taking place. I never want the notoriety and exposure of the conservation ranching program to overshadow or outpace the legitimacy and integrity of the conservation ranching program. I think that's this program was built because of a crisis that's happening in grasslands and grassland birds, and we should make sure that the enrollment and the values that are behind the seals are underpinned by good data that we collect on an ongoing basis.
Great. Thank you so much, Marshall.
Absolutely.
And the coronavirus is pretty heavy up there in the Dakotas, so be careful.
I appreciate that. We are definitely spiking, so keep us in your thoughts.
Well, right. Again, thanks so much.
Thanks a lot. Thanks for having me.
Yeah. I can't really applaud, but I'd love to. We had programmed a 10-minute break in here, but I don't know if we really need to take advantage of that. Let's see. Oh, I wanted to tell you that the question that went with the conservation ranching segment was, would America's greenhouse gas emissions really decrease by 40% with the elimination of cattle? And it's a yes or no response. So if you start collecting the answers to these 4 questions, which I'll repeat at the end, and then email them, we'll enter you into the drawing for the $50 gift certificate. So again, would America's greenhouse gas emissions really decrease 40% with the elimination of cattle? All right. Is Valerie with us?
I'm here.
Great. Oh, hi, Valerie. Up next, we're going to hear from Valerie Kearny. She graduated from the University of Georgia in 2016 with a BS in Wildlife Sciences. And then she worked for the Center for Environmental Management of Military Lands in Fort Campbell, Kentucky. And this is really a fascinating thing. I'd love to talk to her about that. But, and then she went on to the New York State Department of Environmental Conservation. In 2019, she started her master's degree work at Arkansas State University. She's going to tell us about the searching for small-footeds, distribution, and roost preference of Myotis libii. You can fix that later when it's your turn. As you listen, pay attention to the mention of white nose syndrome if you're going to be entering the quiz. All right, take it away, Valerie.
Awesome, thank you. Let me set up this screen sharing here. All right. All right, guys. So thank y'all so much for having me. I'm going to be talking about small-footed bats. So here we go. So just to get started, I kind of want to highlight the extreme diversity of bats. There's about 1,400 species of them worldwide. We have about 50 species in the US, and these guys inhabit so many different habitat types. So in the US, you can see from this map here, in Arkansas, the Ozarks and Ouachitas kind of represent hotspot areas of diversity for the eastern half of the country. So it's really exciting to work on bats in Arkansas. So bats are very important to many different ecosystems. They are pollinators, seed dispersers, really important for nutrient cycling, especially in cave ecosystems. And they also provide billions of dollars worth of insect control in the United States, which is very important to farmers and people like us in the Delta with a lot of mosquitoes. So I'm going to be talking about the eastern small-footed bat. Like many bats, this species is threatened by habitat loss and white nose syndrome. So in 2018, the International Union for Conservation of Nature listed them as endangered. However, prior to that, the U.S. Fish and Wildlife Service denied them listing on the Endangered Species Act. And a large part of this was due to discrepancies in decline rates and kind of just an overall lack of data. So white nose syndrome is a disease caused by a fungus that is an invasive fungus thought to have been brought by humans from Europe, and it is spreading across the country and just decimating so many bats of various species in its wake. And we do have it right here in Arkansas. So the small-footed bat, why is there a lack of data on this species? Well, they don't really appear in a lot of our traditional bat survey methods. So for hibernaculous surveys, where they go into caves to count bats, these guys aren't just hanging out on the ceiling in the open like a lot of species. They're usually kind of hidden in nooks and crannies. And then for summertime surveys where mist netting happens at night, these guys are also not really showing up in those. And this is thought to be because they are only appearing on the landscape in concentrated areas associated with rock formations. And there is some pretty big discrepancies in decline rates just because of such a lack of data on this species. So you can see from this chart, we have estimates all the way from 12% to 83%. So that's a pretty large discrepancy there. So small-footeds, Myotis levii was incorrectly pronounced. They are an eastern species associated with the Appalachians and, of course, in Arkansas, the Ozarks. And their distribution isn't really very well known in the Ouachitas, which is the tail end of kind of their estimated range. So you can see that there's only one old historical record from the Ouachita region of small-footeds. So my objectives for this project were to identify the roosting habitat of this species in the Ouachitas, and then I also wanted to determine the habitat characteristics that are influencing their presence across the Ouachitas. So going into this project, I had a few kind of hypotheses and ideas. I was predicting that we would see this species choosing specific rock formation types. And I thought we would be seeing them choosing these in proximity to water and also in proximity to one another. Now, I also thought we were going to see these guys choosing their daytime summer roosts in areas that maximize solar exposure and minimize predation risk. So for instance, where canopy cover is low, and also in very small little areas where many predators like this snake here can't really get into. And I thought we would be seeing these guys, you know, kind of have a backup plan for escape in the instance of predation. So multiple openings, that sort of thing, in case they do need to exit quickly. So to get all of this underway, I first had to review ortho imagery on GIS, so essentially like maps, and look for rock formations across the Ouachita area. And then I needed to visit these to determine presence of the species. I used a few different methods to do that, which I'll talk about in a little bit. I also collected multiple habitat characteristics at these sites through in the field and also later on GIS. And I had to analyze this data. I used generalized linear mixed models, which is just kind of a fancy term for some interesting statistical methods that I will talk about a little later as well. So some of the rock formations that I had as sites in this region are talus slopes, which can be thought of as boulder piles or rock rivers. I also visited glades or barrens, which are generally flatter rocks, and outcroppings, which are a bit more cliff-like in nature. So to detect presence, I used a few different methods because this is such a cryptic species. So first off, when I was visiting these rock formations, I deployed acoustic detectors, which can detect high frequency calls, and I can use software to analyze these calls and break down what genus and whatnot these species belong to. So I use this as an indicator of potential presence. So whenever it came back showing me that there was a Myotis call, that gave me an indication that this species could indeed be in the area. I also visited these rock formations that I had intended to visit. I randomly placed plots. So navigated to these randomly placed points in the field, and I searched a 6-meter radius at those areas. So this would be my plot. And the searching just basically consisted of using flashlights to look in nooks and crannies of rocks to try and find this species. And I also collected various habitat characteristics at this point in time as well. And then when I had sites where my acoustic detectors indicated there was potential presence of Myotis in the area, but I failed to confirm true presence with visual confirmation through rock crevice searches, I then misnetted at the area. And that basically consisted of setting up, very similar to bird mist netting, except at nighttime, as close to the sites as we could get. And here's just a very long list of some of the different habitat characteristics I was collecting. So in the field, collecting canopy cover, an estimate of the amount of vegetation cover of each of these search plots, the vegetation type, things like that. And then of course, also on GIS, I was using these points I made in the field of where the searches were conducted to collect information such as aspect, elevation, the type, the bedrock type. So there was a lot of habitat characteristics I was looking into here. All right, so I'm going to talk a little bit about what I found. So I conducted my research in the summer of 2019 and this past summer in 2020. In 2019, I visited Rich and Black Fork Mountains and also the Caddo Mountain area. Now, we did not find any bats in the Caddo Mountain area. So for 2020, we shifted a little northward and visited Rich, Black Fork, and the Fuchs Mountains, and also went to Mount Magazine, Mount Nebo, Petit Jean, and Pinnacle Mountain. And during this time, I visited about 50 different sites. 11 of those I visited both years. I conducted about 315 plot searches. Bats were found in about 63 of those plot searches. And over the course of the 2 years, let's see, in 2019, we found 17 small-footeds, and in 2020, we found 137. So that was, 2020 was very productive. So just a little bit about their roost characteristics. We commonly found these guys, as I had predicted, in very small little spaces. The bats I look at, small-footeds, only weigh about 5 grams, so they're a very tiny little species. And the average width of the crevices we were finding them in was only about 1.5 centimeters, which is crazy small. And we were generally finding them in vertically oriented cracks with multiple openings. So in this example of a roost in the picture I provided, you can see the bat could exit from the top or from either of the sides. Most of these bats we found roosting solitarily with the occasional small group. And they were found, this is a very good picture of most of the roosts looked like this. So generalized linear mixed models. This is what I used to look at which habitat characteristics were best predicting the probability of presence of this species. So in other words, essentially what are small-footed's habitat preferences. So with mixed models, you're able to account for pseudo-replication. So for instance, I had multiple plots within each site. And the fixed effects are basically the habitat characteristics I keep talking about. So first off, from that list I showed you guys earlier, I looked at an individual model with one habitat characteristic per model and compared it to a null model. And these are the ones listed that performed better than the null. And then from there, I built various combinations to see which combination of habitat characteristics was going to be the best predictor of presence. Now, for the site level, we found that feature type was the best predictor. So that was very obvious without even having to do statistics because we only found bats at talus slope sites. And looking at all of the plots from all 2 years, we found that elevation of the plot, area of the site, and the amount of vegetation cover within the plot were the best predictors of presence for this species. So looking at the predictions based on this model, we can see that as elevation increases, there's a higher likelihood of finding small-footeds. Also, as the area of the site decreases and as the amount of vegetation in this site decreases, there is a higher likelihood of finding this species. So kind of in conclusion to what I was hypothesizing at the beginning, we were seeing these guys have, specific preferences for their habitat. While we didn't find the proximity to perennial water sources to be one of those, one of my thoughts is that as such a small species, ephemeral water sources could probably be supplying their needs. But in summary, we basically found that the higher in elevation a site was, the more the small-footed seemed to like it. The smaller the site was, and also the less vegetation the site had, there was a higher probability of finding small-footeds there. And while we were seeing these guys choose areas of pretty low canopy cover, there was not a significant difference between sites where small-footeds were found and sites where they were not. And this is probably just because rock formations in general have low canopy cover. That is how I found the rock formations while reviewing ortho imagery, is when the trees weren't able to cover it. And on average, the plots with bats in it had about a 15% canopy cover. And again, as I mentioned, we did see what we believe to be avoidance of predation risk with these bats choosing very small roosts that had multiple openings. So one thing I am currently working on that I have not finished all my statistics on yet, but I still wanted to kind of share with you guys. So when I was doing this research, I placed eye buttons, which are temperature collecting units, they're very small, into the roosts where we found the bats. Basically, I wanted to try and look at the microclimate preferences of this species. Bats utilize torpor to help save energy, and so they have very specific microclimate preferences. And one thing that is becoming apparent so far that's very interesting is that the ambient temperature just of the general area is much, much lower than the roosts we were finding these bats in. And we were also seeing these roosts in the rocks staying warmer later into the evening, which makes me think that they're choosing these sites basically to facilitate passive warming to help them save energy. So it's very interesting. I'm excited to figure out a little bit more about that. And with that, I have a bunch of people to thank, the Game and Fish Commission, Forest Service, state parks, and of course, a big thank you to you guys. I really appreciate your support for grad students like myself. And of course, a big thank you to the R Squared Lab and my school at Arkansas State. And with that, I will answer questions.
I already have a question handed to me. It seemed like were there always lichens on the rocks around those crevices?
So yes, in general, let me see if they weren't always as heavily lichened as in this picture at the very end I had, but there was lots of different lichens on all of the rocks, but generally more at the edges. I'm trying to read the...
Well, I want to read this one because it's a nice one. Valerie, outstanding quality of research. Very much appreciate your work as a presenter. You are to be commended for fantastic visual impact of your slides to get your message across from an entertainment perspective as well as educational value.
Thank you.
Yeah, that's a nice one.
That's very nice of you guys. So Jacob has a really great question. If the area variable was site area, do you have any idea why the bats might prefer smaller talus slopes. So that is something that I am not really quite sure about. When that first kind of appeared, I was wondering if it was because, you know, if it's a smaller site, there's just a higher probability that where my random plots were placed would be on a spot where a small-footed was, whereas at a larger site, the small-footeds could be more spread out, so the likelihood of me just randomly happening to find one was less. So I'm not sure exactly why they, I think it might just be the chances of my detection, which there is definitely a level of detection error because there could be sites where I just didn't find small-footeds, and they could be there. So did you find any giant earthworms while you were looking for your bats? No, but I did find a lot of giant millipedes. They love the talus slopes.
You know,
Any other questions?
I've seen millions of bats coming out of caves in Southeast Asia, and this is kind of the other end of the spectrum. I had never had any idea that they individually would hide in rock crevices. About the last place I would have expected to look for them. Really interesting.
Yeah, bats represent such a diverse array. There are a lot of colonial species, and so this is kind of a rarer phenomenon from what we're used to hearing about, is these solitary roosting species, especially ones in rocks. In the western half of the state, rock roosting bats are a bit more common than over here. We have a lot more forest-dwelling bats.
Caitlin wants to know if snakes were frequently occupied some of the same roost sites.
So yeah, we not super surprisingly had a lot of different herpetofauna that we found during our searches as well. So timber rattlesnakes were a pretty common find. And I would say the main difference between the actual locations we were finding the bats versus where we were finding like snakes and lizards and things like that is the bat crevices were about this wide. Like they were really wedged in there. I mean, 1.5 centimeters, that's like my pinky. So they're very wedged in there and they're very little. So it was interesting that they would be on the ground like that though.
All right. Well, I have a feeling that Karen has said it all. I would like to second her compliments to the presentation. Thanks so much. The question that goes with this particular presentation is, white nose syndrome is threatening many Arkansas bat species. And this is the kind of question that I love because it's true or false. White nose syndrome is threatening many Arkansas bat species, true or false? So if you think you know the answer to that, you can add it to your list. I'll put all of the questions in the chat box a little bit later. All right, let's move on here. Let's see. I've got to get my cheat sheet. Jacob, are you ready?
Yes, I'm ready.
All right, great. Jacob Wessels, he completed his master's degree at Arkansas State University. I think it was earlier this year. Before that, he completed a Bachelor of Science at the University of Tennessee, and he worked as a research technician on several science projects involving birds and amphibians. He apparently has a disease that many of us share. He says he is an avid birder and enthusiast. A nature enthusiast. So that bodes well for the future, Jacob. I can assure you, if you have a passion for birds, it'll give you lots of great adventures. Jacob is going to tell us about his research on Cerulean Warbler ecology along the Buffalo National River, which is where I am right now. As you listen, pay attention to what is considered to be the main threat to these warblers. It's all yours, Jacob.
Okay, great. As Jack said, I'm going to be talking about the research I did for my recently completed master's degree at Arkansas State University on cerulean warblers on the lower district of the Buffalo National River. So many of you might know that cerulean warblers are a migratory songbird species that breeds in the eastern US and Canada. They have a pretty patchy breeding distribution though. And on the right, there's a male shown at the top and a female shown at the bottom. The species does migrate down to spend the winter in northern South America, and they prefer deciduous forests that have complex canopy structure. Cerulean warblers are in decline, however. It's estimated that about 73% of the overall population has been lost between 1970 and 2014. The Collaborative Conservation Organization Partners in Flight has them on their reverse decline watch list, which is for species where they want to reverse the decline, and that's one of their yellow watch lists. Specifically in Arkansas, they're considered a species of greatest conservation need. And habitat loss is thought to be the main factor driving the decline of this species. Cerulean warblers do show a lot of ecological variation though. So although they overall will select deciduous forest habitats, in some regions they're found more in riparian areas, so along rivers and other bodies of water, but in other regions they're found on high mountain slopes using forests there. Previous studies have also shown that the species shows a lot of regional variation in their reproductive success. Additionally, data from the North American Breeding Bird Survey suggests that population trend and whether populations are increasing or decreasing might vary regionally as well. That's shown in the map on the right, where the different colors indicate different levels of increase or decrease. So overall, this ecological variation really suggests to me that understanding the regional and local populations will be important to conserving the species overall. Specifically, cerulean warblers have been understudied in the Ozarks, and that's really what has motivated this research that I'm talking about. So going off of that, our objectives in this study were to assess their habitat selection in the Ozarks at multiple spatial scales, to estimate their nest survival and describe their breeding biology in this region, because nothing previously had been documented about that, to estimate the apparent within-season survival and the annual return rate of males, and finally to estimate the territory sizes of male cerulean warblers. We did this research in the lower district of the Buffalo National River in northern Arkansas. For those of you who are familiar with this area, we did this research at several sites from Maumee North on the upstream end down to Rush Landing on the downstream end. And most of this research was completed in 2 field seasons. So this was from April through July in 2018 and 2019. And then we did do some additional field work earlier this year as well. When we were in the field, we captured cerulean warblers and we banded them with unique combinations of plastic color bands, which are visible on the legs of the lower bird. And that enabled us to identify individuals following their initial capture without recapturing them. Then after that, to estimate the survival of males, we conducted search effort to recite males both within the breeding season weekly, and then we also recited males each year in the field. We also mapped the territories of banded males, and to do that, we followed select banded males and recorded the locations that the males were using. We also searched for warbler nests by observing their behavior. And then, because this species mostly nests high up in trees, we monitored nests using spotting scopes. And that enabled us to determine whether there was activity at the nest and watch for things like nestlings or incubation behavior. We also measured habitat characteristics. And this was a whole suite of habitat variables that previous studies have thought to be important to habitat selection by this species. This included things like vegetation structure and tree species and topography as well. We measured these features at used and randomly selected points so we could get at the habitat selection of this species. And we did this at multiple spatial scales. So territory, nest patch, which is the area around a nest, and the actual nest site location. I've pretty much skipped over my data analyses here because it's a little dry, but if you have any questions about that, I would be happy to answer them later. But right now, while I'm talking about my field research, I really wanted to emphasize what an amazing place the Buffalo National River is. I've got a selection of images here from my field seasons, so there's certainly some incredible views there and some intermittent waterfalls as well on our study sites. We also saw a great diversity of birds, both birds of prey and songbirds, and also mammals like the opossum and the beaver shown here. And here's some additional images. We saw a great diversity of flowering plants and some additional birds and a coach whip snake down in the bottom second from the left as well. We did run into some challenges during our field seasons. I guess that's typically the case, but anything from getting some flat tires on a rental car to coming upon a shaft or some kind of pit in the ground that I'm very glad we didn't fall in. We also had to deal with sometimes not being able to access our study sites because of high water. Thankfully, we did heed the signs, unlike the Jeep in the lower right photo that was swept off one of the creek crossings on Rush Creek when they tried to cross when the water was too high. It's my understanding, though, that the occupants of the vehicle were fine. We also ran into some animal hazards during our field work. So 2 species of venomous snakes, timber rattlesnake and copperhead. Either fortunately or unfortunately, we didn't run into pygmy rattlesnakes, but I heard afterward that they were in the area as well. Also, semi-feral cute kittens and cows in the road, and at the bottom center there is a feral hog. Those are much more of a problem in 2018. Thankfully, we didn't see nearly as many of those around during the 2019 field season. And this was in addition to the usual array of biting and stinging insects and arachnids. Getting into our results, I'm just going to hit the highlights for what we found related to habitat selection, because we had a whole slew of different variables. What really stood out to me was that we found that cerulean warblers were selecting large trees at each of the spatial scales we looked at. And this was based on tree diameter. So it really seems that they're preferring areas with larger trees. Additionally, we found that males selected territories that were close to the Buffalo River. That's not too surprising based on our field observations, because males were usually setting up territories within a few hundred meters from the river, and we would seldom see cerulean warblers too much farther away from the river. This result is probably not consistent with their habitat selection in other areas of the Ozarks, so the upper district of the Buffalo National River and also areas in the Ozark National Forest. They'll use forests on high mountain slopes and not necessarily just riparian areas like these birds. So again, that emphasizes the within region variation in their habitat selection behavior. More generally, we did find both similarities and differences with studies from other regions. So that again emphasizes the ecological variation that this species shows. Okay, getting into breeding biology, we located 33 nests. That's across both 2018 and 2019. And our model estimate of overall nest survival was 32%. That's pretty intermediate relative to estimates from previous studies. So previous research has found anywhere from about 7% to 76% nest success. We also attempted to count the number of nestlings in a nest, or the brood size, but we were often unable to do that because of the steep viewing angles to nests or because of things like leaves blocking our view. But when we were able to count the brood size, it was always 3. That's pretty consistent with previous studies. 3 to 4 is the average brood size for this species. Finally, the nesting season that we observed was from about late April to late June. But that probably depends on things like how fast the spring warms up. And some individuals may be nesting a little later than that as well. Thinking about survival, our within-season survival estimate suggested that within-season survival of males might be a little lower than some previous studies, but we can't rule out with our methods that some of the birds might have just been dispersing off of our sites within seasons. For annual survival, we found a 29% return rate of males between the first 2 field seasons, but then only an 11% return rate between the second 2 field seasons. Previous studies of the species have found varying return rate, so our study fits in pretty well with that. And again, we can't rule out with our methods which birds may have died versus which birds might just have not returned to the same sites. Thinking about space use, our estimate of mean territory size was 1.14 hectares, and that's about 2.8 acres. That's larger than most previous studies' estimates. It's really difficult to compare these estimates between studies. Not only are there ecological factors that could be varying, like things related to habitat quality or the density of Cerulean warblers, but the methods that researchers use to estimate territories also differ among studies. So overall, this makes it pretty difficult, in my opinion, to say anything about the differences that we see. The map on the right shows the estimates of the territories of 3 males from 2018, and that's pretty typical of what we saw at our study sites. So the territories are pretty much just lined up along the river, and again, we seldom saw males that were spending much time too far upslope from the river, probably more than a couple 100 meters. So thinking about future directions that studies could take, I think that continuing to study Cerulean warbler ecology elsewhere in the Ozarks will be important. Like I was saying earlier, the variation that the species shows in its ecology, both between this study and previous studies and between anecdotally this area of the Ozarks and other areas of the Ozarks, suggests that further research will be needed if we really want a comprehensive understanding of what this species is doing. Another question that I think would be interesting is whether the heavy recreational use of the Buffalo National River might impact this species. There's often very heavy float traffic during the summer months, and also heavy use by people camping, and Cerulean warblers are also found in those same areas. So I'd be interested whether the disturbance could be negatively impacting these birds. Finally, more generally, the movements and dispersal of small songbirds is, I think, a really important area for continued method development and continued research. I think that'll really bolster our understanding of bird populations. With that, I'd like to thank everybody who made this research possible, both through helping me in the field and through their advice, including my thesis committee. And I'd also like to thank my funding sources. Importantly, the Arkansas Audubon Society Trust contributed grant funding, and that really helped make it possible for me to hire field technicians, which in turn, I think was really an important factor in allowing this research. And with that, I'd be happy to take any questions you all have.
Well, thank you, Jacob. I'm really pleased to see your plug for the Buffalo National River. I wonder if there's not a constraint on the part of the warbler habitat, because the Buffalo River is such a thin, has thin boundaries on either side of that river. And so I'd really be interested if you do follow up with the recreational use and its impact, because of course, without the recreational impact use, there might not be a Buffalo National River. So it's kind of
yeah, that's not something that I have plans to do right now, but I think it would be, that's something for somebody to do. And I definitely agree that it would be interesting, and potentially other species might be impacted by all that heavy recreational use as well.
I see Dan has asked, why do they stay near the river, and how would you test recreational use in ceruleans?
Okay, cerulean warblers are, as I said, they prefer forests with diverse canopy structure, like a lot of tree fall gaps. I don't necessarily have a definite answer for why they're staying by the river, but I think that the habitat by the river seems kind of consistent with their tendency to use areas with lots of tree fall gaps, and the forests are just a lot, based on my experiences on the buffalo, they're a lot more, like the canopy structure is much more diverse by the river. There's more tree fall gaps, there's more vines, and it's just a lot, it just looks different than the forest farther away from the river where there's less tree fall gaps, it's a lot less understory, and I think the Ceruleans are probably selecting the forest features closer to the river.
I guess you're,
I don't necessarily think it's
go ahead.
wood edge effects. I think it's more of a disturbance, canopy disturbance thing, maybe. That's just my speculation, though.
I guess
for predominant tree species used, we did analyze some tree species, and we found a suggestion that they might avoid white oaks in this region, which is unexpected. But other than that, there did not seem to be any predominant tree species that they were choosing. Based on all the previous studies that have been done, it seems like I would speculate they probably go more off of like tree structure than species, because they use such a diversity of species, although they do prefer white oak in some areas. And let's see, regarding testing recreational use, one thing that I would think about is looking at something like nest survival and whether it's close to disturbance like a campground or a road. Anecdotally, we had one bird that nested directly over a road and that failed. But we didn't really have the sample size to test anything like that, but that might be one way to get at that sort of question.
All right, well, thank you very much. The question that the Cerulean Warbler is a multiple choice one. Which is thought to be the main threat to Cerulean Warblers? Overexploitation, that's A. B, habitat loss. C, pollution. Or D, invasive species. Which is thought to be the main threat to Cerulean Warblers? A, overexploitation. B, habitat loss. C, pollution. D, invasive species. And again, I'll post all these at the end. All right, Jacob, thanks very much. All right, Kevin, are you ready?
Yep.
All right. Kevin Krajcir entered and if I murdered that, fix it after, entered the world in Hot Springs, Arkansas. He tells us, in spite of living near a national park, he didn't gain a true appreciation for nature until he attended Hendrix College. And this is kind of neat. Kevin credits the origin of his passion for nature, and particularly birds, to working with Dr. Maureen McClung. Kevin is a major contributor to Arkansas Audubon Society. He's a member of the Ecology Camp Committee, instructor at the Haltberg Ecology Camp, and he's also the chair of the AAS Publicity Committee. At Arkansas State, he serves as a graduate teaching assistant. He's going to tell us about his research on feather mites. Environmental context mediates the functional relationship between feather mites and hosts. As you listen to this, pay special attention to the various roles mites play in feathers of birds.
All right. Thank you for that great introduction, Jack. So yeah, I'm Kevin Krajcir, and like Jack said, I'm a master's student at Arkansas State University working under Dr. Thombovis for my master's. So let's get into some of my research that I am in the works of publishing because we finished it up. So there we go. I'm sure when most of you heard or read the title of this presentation, you thought of typical ectoparasites of birds like ticks and lice and other mites perhaps, respiratory mites, nest mites. However, here's my disclaimer that not all symbiotic interactions can be so easily categorized. And as we'll see, one example of that is feather mites, and I'll just be referring to them hereafter as mites. These are mites that specifically habit the wing and tail feathers of their avian hosts, where they consume microbes such as bacteria and fungi that grow on the feathers, and some of the uropygial oil that the hosts secrete onto their feathers for feather maintenance. Again, like I said, this is an example of a symbiotic relationship between the mite and the bird that we really don't have great conclusions about. The literature, as I've shown here, a couple examples, mentions the possibility of all kinds of conclusions, including parasitism, commensalism, and mutualism. However, we believe to attribute this to a typical lack of breadth in study scopes. So a lot of studies will look at just one species or just one site, and then say, oh, this is the relationship you're getting for all the interactions between mites and birds, but that's not necessarily the case. You need to look more broadly. That being said, though, a lot of studies have looked at factors that influence feather mite abundance, and I've listed a bunch here that I looked at in this study as well. So temporal factors like the time of day, climatic factors like temperature, humidity, and precipitation, geographic features of the site, and some host-specific factors like species identity, age, and then nesting, habitat, and ecological stratum. Like I said, various studies have looked at these and come to different results that I've kind of included in parentheses briefly here just to show you. And they've indicated that this could be due to both direct and indirect effects of these things on the host, or on the mites. So for example, we could very easily imagine a scenario where mites become more abundant on hosts that live in warm, humid environments. Remember, these mites are going to be small, ectothermic arthropods, so they really depend on the host for all of their nutrients, their water absorption, all of that. So they like it, like anything else, humid and warm so that they can survive and reproduce. That warmth and humidity, though, may also be attributable to indirect increases in mite abundance. More humid, more warm environments tend to result in greater numbers of bacteria and fungi. And so that can be indirectly providing more food for mites, thus increasing their abundance as well. So there's various mechanisms by which these contextual factors can influence mite abundance. That being said, in turn, this mite abundance, whether it's high or low, has the potential to affect the direction and strength of the impact of the mites on their host. We can easily imagine a sort of mutualistic example whereby having more mites, the host's body condition or fitness or some metric of the host's condition is increased as well. One example of that may be that having more mites results in more consumption of detrimental feather microbes, so like feather degrading bacteria, feather degrading fungi. So if you have more mites to eat those, then the mites are essentially acting as feather cleaning mutualists. On the other hand, we could also imagine a parasitic example whereby the mites are perhaps consuming too many beneficial bacteria that could throw off the balance of the feather's microbiota, or perhaps they're consuming too many uropygial oils that the host uses for various feather quality processes and other things. So with all that in mind, we wanted to explore how various contextual factors could mediate both feather mite abundance, and then how those factors also mediate this relationship between feather mites and their hosts. So we have various predictions about how these contextual factors will increase, decrease, or not affect feather mite abundance. Those were kind of based on the findings of other studies that I showed a couple slides ago. And also we wanted to look at, we predicted that the direction and magnitude of the effect that these mites have on their host's condition, both body condition and apparent survival, will depend on these contextual mediators of the relationship. So for my study, we looked at 7 species of New World warblers, including American redstarts, black and white warblers, cerulean warblers, common yellowthroats, northern parulas, prothonotary warblers, and yellow warblers. Specifically, we looked at breeding males of these species because they were easier to capture, work with, recite, and all that. And choosing these species really allowed us to explore a variety of life history strategies, as well as a variety of contexts. So obviously, some birders may know you kind of have to go to certain habitats to find certain birds. For example, the prothonotary warbler really prefers swampy sort of habitats versus things like the northern parula, and the cerulean warbler may prefer canopy nesting habitats, so very forested. So you get different habitats when you go to search for these birds. Also, we looked across the range of these species, well, their breeding ranges, to get that sort of variation in where we explored this relationship. So on the map to the right, you're able to see all of our study sites. This includes some of the swamps in southern Louisiana, even up to the forests in northern Wisconsin, and some of the mountainous terrain of Idaho. So with that, obviously, we're getting a lot of geographic and climatic variation across which these hosts are living and where, you know, they're interacting with their mites. So at each site, we would go out and locate territorial males based on visual and audio cues. We would capture them using mist nets and playback recordings. Then we banded the birds with a USGS aluminum band and unique combinations of color bands so that we could identify them without having to recapture them. Also on site, we took data like the date, time of capture, the age of the bird, various morphometrics of the bird, including mass and wing chord, some metrics of site geography, and then we also took photos to estimate feather mite abundance. So we took photos of the wing and tail feathers in the field, and then we digitally magnified these photos to be able to count individual mites. So this kind of bigger photo, I'm sure you can see all of those. I describe them as like little pepper flakes. Those are all individual mites. Some of them are either eggs or juvenile mites. So we counted all of the mites on the wing and tail feathers to get an estimate of total mite abundance on that bird. Off-site, we collected our climatic variables by going onto the National Oceanic and Atmospheric Administration's website. And we would get average temperature, total precipitation, and average humidity from local weather stations nearest to our sites. And we would get those variables for a period of time depending on if we were looking at mite abundance or body condition versus apparent annual survival. The period of time reflects kind of when we expect those climatic factors to have the most impact on the bird-mite relationship. To assess apparent annual survival, we would revisit the sites where we originally captured the birds, so the following years. From the central location of the GPS point, like where we found the bird, we would walk 500-meter transects in each direction, so a 500-meter radius, looking for any individual of the same species. We would lure them in with playback and get a look at their legs to see if they had those color bands that we placed on them. And if they did, and we were able to identify the individual, we marked them as having survived. We gave this 2 attempts. The first attempt, if we didn't find the bird, we went back for a second attempt. However, out of our about 120 birds, 46 returned. Most of them on the first attempt of recite, we were able to find them. And overall, this gave us about a 37.7% return rate, which is pretty typical for warblers. I won't bore you too much with my statistics, but just letting you know that I did a variety of modeling depending on the type of response variable we were looking at. So whether we looked at feather mite abundance, body condition, or apparent survival. And those models were compared and appropriately selected using various frameworks in Program R for statistical analysis. So getting into the fun part of it all, understanding what actually has an effect on stuff. So looking at mite abundance as the response variable, we found that humidity had an interaction with Julian day, so day of the year, and actually the quadratic version of that variable, as well as species identity and precipitation. So for this, that was the the best model that we were able to find. But this graph is just showing variation in mite abundance both within and across species. So as you may note, birds like the Cerulean Warbler, the common yellowthroat, and the northern Parula tended to have a lot more mites than, say, the black and white warbler and the yellow warbler, which most often had 0 mites. It's noteworthy too that there was variation within a species. I think the best example of that is the common yellowthroat. We had some, I believe, that had 0 mites, but then you see this little black dot way at the top. We had one common yellowthroat that almost had 6,000 mites between its 2 wings and tail feathers. So that goes to show that there's tons of variation within and between species in their mite abundances. Also, an image from this model. So this is showing the sort of interaction between day of the year and humidity and how those impact mite abundance. So looking at this darker line that's decreasing, that's dates that are earlier in the year, so earlier in the breeding season. We saw that an increase in average relative humidity led to a decrease in mite abundance. And then we saw the reverse of that later in the season, where an increase in humidity corresponded with an increase in mite abundance. So to kind of explain that relationship, I'm having to throw in precipitation because it was part of the best model, although I didn't really depict it in the graph. I believe it does have something to do with why we observed this relationship. So earlier in the season, if we saw increases in humidity, we may attribute those to increases in precipitation. And I'm sure you can imagine, cold, rainy spring, late winter, we get a lot of rain or a lot of snow, maybe not here, but in other locations, they get a lot of snow. So earlier in the season, we're seeing lots of precipitation, perhaps associated with extreme weather events, such as cold snaps or, deluges of rain. All of that could really impact mite abundance negatively. So, remember, mites like warm weather. If there's tons of rain, maybe the host is just getting bombarded with rain. It's washing the mites off of them, perhaps. That might be an explanation. Versus later in the season, I'm sure we've all lived through a nice hot Arkansas summer and experienced that humidity for ourselves. We see increases in humidity, however, not as much extreme weather. And so without that extreme weather, but still having high humidity, maybe the mites are able to survive and reproduce better such that their abundance can increase. Moving on to body condition, our best model included an interaction between mite abundance and humidity. So humidity is kind of showing up again, as well as capture time. But I'm going to focus on this interaction between mites and humidity. So for low humidity sites, it's this gray line that's increasing. We saw that mite abundance, higher numbers of mites at low humidity sites tended to have a positive effect on body condition. However, higher numbers of mites at high humidity locations tended to have a negative effect on host body condition. It's interesting to note here that mite abundance by itself did not affect host body condition alone. It was once we added humidity and other variables that we started to see mite abundance having an effect. So I think that's a really interesting way of, or really evident result that there is context dependency in this relationship. And it's only when you account for other variables like humidity that you're able to see that. So kind of attempting to explain the possible mechanism between mite abundance and humidity's effect on host body condition. We saw increases in humidity relating to increases in mite abundance. That makes sense based on what we talked about on the previous analysis. Those increases in mite abundance may be related to decreases in uropygial oil or increases in mass on the host. So as mites get more abundant, they're probably eating more of that uropygial oil, which confers different benefits to the host. Or, as they're getting more abundant, they actually just weigh more on a feather. And obviously with birds, they're going to want to be as light as possible. That's the whole point of how birds' bodies are designed, so that they can fly. Both of those together or perhaps separately may have a negative impact on body condition, as birds have to spend more energy producing uropygial oil to replace what's lost, or more energy carrying around these potentially heavy mites. That leaves the bird less energy to expend on other things that it needs to spend energy on. As for apparent annual survival, our best model did include mites and host stratum. However, I will just kind of skip over that graph because the relationship was actually not meaningful. Mite abundance didn't, although it showed up in the model, didn't actually have a meaningful effect on apparent survival when we looked at the metrics of that. This could be due to a variety of reasons, including the fact that host apparent survival is fairly crude in terms of an estimate of host condition. As Jacob kind of talked about with his presentation, we're only able to confirm that the bird is still alive. We can't confirm that it's actually dead or that it dispersed to a new location 50 yards away and we just missed it. Perhaps that's what's happening. So we're not able to really confirm death or dispersal, just that the bird survived. Also, mites are pretty small, of course. Perhaps they just have very minor effects on the host. And that doesn't show up in something as long-term as apparent annual survival. Like, that's a whole year of the bird's life. Maybe the mites aren't having such a strong effect on that survival. And likely their survival is, or their site fidelity is more dependent on other factors, such as breeding success and a variety of other things that the mites may not be able to affect. However, we should keep in mind the potential for thresholds. Perhaps birds that have over 3,000 mites don't survive as well or survive much better. So there's need for more data on that to be able to tell if there actually may be effects of mite abundance on host survival and what conditions allow for that relationship to take the shape in the way it does. So concluding, it was great that we were able to find context dependency in the effect that mites have on host body condition. However, we weren't able to find this for apparent survival. Obviously, that's really interesting in light of climate change because, as you saw, humidity, precipitation, a lot of climatic factors showed up in our modeling. So how those factors are changing with climate change and what those changes might mean for this symbiotic system as well as other symbioses is really interesting. And obviously this system and others warrant more study so that we can have an understanding of how climate change may impact both the mites and their hosts. That being said, we do want to look at this relationship across even broader contexts. So, we only looked at 7 warbler species, but adding others into this mix could be really interesting. Also getting more direct measures of host fitness, such as physiology, various immune and endocrine metrics perhaps may be more indicative of other effects of the mites. And we also want to include experimental studies, so adding or removing mites to see what might happen to a host when you force those conditions under them or change the humidity in which the mites live. And so our lab is constantly exploring new projects in the realm of feather mite biology. And with that, I'd like to thank my collaborators, including my lab mates, both graduate and undergrads, and of course a special shout out to the Arkansas Audubon Society Trust, who funded portions of this research so that it could get done. So with that, I'll be glad to take any questions.
Great. We've already got 2 questions and a comment. How do mites keep from being physically separated from their host when the host takes flight?
Yeah, so they have a variety of anatomical features that allow them to attach to the host feathers. So they have various setae, which are just like little hairs that hang off their body. And mites also have these little like suction cup hands called, I think they're the ambulacra, that they'll just grab onto the host with. These mites do live between the barbs of the bird, so along the barbules, so the structures that already interlock to give the feather its structure. So the mites are really good about holding on to that. Also, their bodies are really compressed so that they can withstand the forces of flight while the birds are moving around.
Tag on to Barry's question. What about preening? Does that remove some of the mites when birds are preening?
Yeah, so there was actually a really cool study, I think in 2018, in Darwin's ground finches that suggested that hosts have evolved their beaks. So some of those finches have, kind of like our crossbills, they have beaks that sort of overlap into a weird shape. And that study suggested that those birds evolved to be able to use their beaks to, like little tweezers, to pull off the mites. I don't know that birds, at least our birds around here, actively do too much to remove mites specifically. Again, if the mites aren't really that much of a problem, if they're doing good to the bird or if they're just there, I don't think it behooves the bird much to spend time preening them. If they have feather lice or something like that, maybe a tick, maybe that they'll scratch at it a little more. But
Melinda is wondering, when do mites breed?
So I'm going to think that that's going to be a year-round sort of process. I looked up, and that kind of had to do with when we decided to pull climate variables. So I think I found for another type of mite that their lifespan is 45 days. So they're constantly probably reproducing. They do get more abundant, I'm sure, during the summer months, during the breeding season. However, I would say for some of these warblers, since they do overwinter in nice warm tropical locations, I'm sure they're keeping, pretty abundant mite loads year round. But for our overwintering birds here, we really don't see a lot of mites on them. So things like pine warblers or yellow-rumped warblers that live here year-round, Thon has said that he's caught some of those and found very few mites, if any, on them. So again, that temperature may sort of play into that. They will reproduce, I'm going to say, pretty constantly, though, in order to keep up with just their natural life cycle. And during the reproductive season of birds, so their hosts actually, that's when a lot of mites take advantage of the time to switch from parent to offspring. So the time in the nest is when a lot of mites will jump ship onto the chicks once their feathers are well developed enough, and start a new life and colonize that new bird there. So
Robin asks, do you think the relationship between mites and birds is mutualism, commensalism, or other?
So I'm going to say it's probably, under most conditions, commensalistic. However, this study and others, if you were to do like a more comprehensive like meta-analysis of everything, I feel like most are pointing towards commensalism, but then you get, under certain contexts, you get that mutualism. Under other contexts, you get parasitism. I really think, like, if you want to find out what a mite does to your species of bird, like, you need to do that study, because it's really going to be an individual basis. So, barn swallows in Nebraska, in some studies, have shown positive relationships. But if you look at, I think the other example I had on there, the Seychelles warbler in the Seychelles, then it's going to be commensalistic. So really it comes down to where your species is and what your species is and what the context of that interaction is. But generally, that's what we hope to pull out of this, like, major trends, to be able to say, generally, under this humidity regime and this temperature regime, you can expect this relationship. So
fascinating. So lots of questions, lots of opportunities for more research there, it sounds like.
Yeah, and Dan pointed out the need to measure microbe load, which is something I've been interested in doing. I'm actually taking microbiology right now and trying to learn a bit about how to do all that. So my friend and collaborator in our lab, Alex Matthews, she's actually doing her PhD, doing a lot of the genetics and stuff about feather mites. And I think her and Thon are working right now on answering that question of microbes, or looking into it a little bit, seeing what microbes are on the feathers and what that might mean for the mites and the birds. So
Okay, the question that goes with this presentation is a true and false question, and it's feather mites always act as parasites, true or false? And if you look over in the chat there, I've posted all of the questions for the 4 presentations. And if you want to try to answer those, you just have to go 1, 2, 3, 4 and put the answer next to it and email it to fellowshipofthewings@gmail.com. And let's see if we can wrap that up by Sunday evening. And I'm just now copying, and I'm going to post the place you go if you were interested in the Blue Nest beef company that Marshall mentioned. That's where you can go to order that. It comes to your house in dry ice, and so it's pretty safe and pretty good. All right, I think we're at an end. It's been really fascinating. I thank all the presenters and all of you for taking part in this. I would love to, since I've got 3 ASU folks here, to sometime talk to you about the possibility of starting an Audubon campus chapter at ASU. You'd be the second one in the state. And there are about 100 Audubon campus chapters around the country, and the number is growing. And it seems like ASU would be a prime place to have a chapter. So I'll be in touch with you about that later. For everybody, remember that this link also allows you to listen in on tonight's presentation. I'm really anxious to hear about monotypic bird families of the world, and that starts at 7. So again, thank you. There was no essay question here, but if you want to write an essay, you can write in to fellowshipofthewings@gmail.com and tell us what you thought, and also any suggestions you have for our next symposium. Bye, everybody.